In the introduction, we talked about how to solve problems like this one in under 5 seconds using an additive method. You bring down the first digit and then add in sequence. Your last digit is your remainder amount. Answer this question in under 5 seconds using base division. Bring down the first digit, 3, add it to the next digit to make 5. 5 is the remainder amount, so the answer is 3 5/9. Let's take a closer look. 9 is close to 10, so we use 10 as our base. Just like in base multiplication, the number of zeros in the base number equals the number of zeros on the right side of the answer. 10 has 1 0, so we separate out one digit at the end as the remainder. 9 is 1 less than 10, so write 1 just under the 9. So at each step, we'll be multiplying by the number 1. Bring down the first digit, 3. 3 times 1 is 3. Write the 3 in the next column. Adding the next column, 2 plus 3 is 5. So the remainder is 5/9. And the answer is 3 5/9. Using base division, divide 21 by 8. See if you can figure out how it's done. 8 is close to 10, so we'll use 10 as our base. Our base has 1 0, so we'll separate out one digit on the right side. 8 is 2 less than 10, so write 2 just under the 8. Bring down the first digit, 2. 2 times 2 is 4. Write the 4 in the next column. Adding the next column, 1 plus 4 is 5. So 5 is our remainder. The answer is 2 5/8. Divide 46 by 7 using base division. 7 is close to 10, so we'll use 10 as our base. The difference is 3. 10 has 1 0, so we'll separate out one digit on the right side. Bring down the 4. 4 times 3 is 12. Write the entire amount 12 in the remainder column. Adding 6 to 12, we get 18. So we have 4 18/7. 7 goes into 18 2 times with a remainder of 4. So carry 2 to the left. 4 plus that 2 is 6. So the answer is 6 4/7. Using base division, divide 876 by 99. 99 is close to 100, so we'll use 100 as the base. And the difference is 1, but we write 0 1. There are 2 zeros in the base, so we set aside 2 digits in the right side remainder column. The first step is to bring down the 8. 8 times 0 1 is 0 8. But where does it go? Well, we already dealt with the first column, so now we start at the next column over. The 0 goes under the 7, and the 8 goes under the 6. Since we've made it all the way to the final column, we can stop and tally up our totals. In this case, there aren't any carried amounts. The answer is 8 84/99. Using base division, divide 2345 by 112. 112 is close to 100, so we'll use 100 as our base. 100 has 2 zeros, so we'll set aside 2 digits in the right side remainder section of the answer. In this case, the divisor is greater than the base number. What amount do we need to add to get to 100? You need to add -12. But instead of writing -12 under the 112, let's write it as -1, -2. Bring down the 2. 2 times -12 is -24, which we start writing in the next column. Instead of writing negative 24, we write negative 2, negative 4. We need to indicate that each digit is negative because shortly we'll be tallying in columns. The next step, 3 minus 2, is 1. 1 times negative 12 is negative 12, which we write in the next column over as negative 1, negative 2. We've made it all the way to the last column, so let's tally up. 4 minus 4 equals 0, minus 1 equals negative 1. 5 minus 2 is 3. But if we write it as 3, then the remainder looks like negative 13, when in fact, the last number is positive, so let's write it as positive 3. We can't have a negative number in the remainder, obviously, so we keep working. The remainder is actually negative 10 plus 3, which equals negative 7. So the answer at this point is effectively 21 and negative 7 over 112. And that's the same as 20 plus 1 plus negative 7 over 112. And that's the same as 20 plus 112 over 112 minus 7 over 112. So the final answer is 20 and 105 over 112. Using base division, divide 10,000 by 817. 817 is close to 1,000, so we'll use 1,000 as the base. The difference, or complement, is 183. That's each from 9 and the last from 10, 183. If we treat this problem normally, we'll be multiplying by 8. Multiplying by 8, we know, is likely to cause carrying to the left. In this particular case, it's not going to, but when you see an 8 or a high number like that, it's likely to cause carrying. So there's another way to do the problem. 183 is the same thing as 200 minus 20 plus 3, which you can write like this: 2 minus 2 plus 3. That's called the substitution method, and we have smaller numbers, which are much less likely to cause carrying. Let's solve this problem the normal way first. Bring down the 1. 1 times 183 is 183, so we write that in the next column. Adding the next column, 0 plus 1 equals 1. And again, 1 times 183 is 183, which we write in the next column over. At this point, we've reached the last column, so we can start to tally. The left side of the answer is 11, and for the right side, first column adds to 9, second column adds to 11, and the third column adds to 3. So that's 911, which corrects to 1013. It wouldn't be correct to carry any numbers from the right side of the answer to the left side. We want to treat them separately at this point. So the answer we have at the moment is 11 and 1013 over 817. The fraction is obviously bigger than 1 because the top number is bigger than the bottom number. But how much bigger than 1? 1013 minus 817 is 196. So the answer is now 11 plus 817 over 817 plus 196 over 817. And that corrects to 12 and 196 over 817. And that's the answer. Here's the same problem using the substitution method. Bring down the 1. 1 times 2 is 2. 1 times negative 2 is negative 2. And 1 times 3 is plus 3. Adding the next column over, 0 plus 2 is 2. 2 times 2 is 4. 2 times negative 2 is negative 4. and 2 times 3 is plus 6. We've reached the last column, so we can start to tally up. The left side of the answer is 12. The right side of the answer is, 4 minus 2 is 2. 3 minus 4 is negative 1. And 0 plus 6 is positive 6. We don't have any placeholder zeros in here, but we understand this to mean 200 minus 10 plus 6. 200 minus 10 is 190, plus 6 is 196. So the answer is 12 and 196 over 817. Remember that you can always multiply and divide the divisor and the number being divided by the same number in order to obtain the most suitable base to work with.